Hello, and welcome to this training by Ron on linear versus switch mode amplifier technologies. Thanks for taking your time to be with us. We have distributors and representatives from all over the world joining us for this training, and we really appreciate you spending your time on this important topic. It can be difficult at times, maybe confusing to know when would make sense to offer linear technology to a customer, or what are the criteria that would help us to know that actually switch mode technology would be a better solution for that customer. We want to talk about that in detail today. To start this off, we just want to talk a little bit more about where AE Techron is in the industry. Again, there's low frequency and high frequency. On that low frequency end, if we think of that from DC to 5 or 10 kilohertz, that would be our shaker tables, DC supplies, industrial amplifiers, that sort of thing. But then we have our high frequency, sort of getting from 10 kilohertz all the way out to multi-gigahertz, and that would be communications and radar and EMP and that sort of thing. We have AE Techron sitting in the middle of all of that. And so our primary frequency range is DC to 1 megahertz. That's where we operate, and our solutions are wide bandwidth, but they operate at that frequency range. We have then, because of that, we're known as a really important provider of both AC and DC power supplies. Our amplifiers can do both, be either an AC or a DC power supply. There's hardly anyone in the world who can provide that kind of a solution. And so that's something that's unique about our products. Also, they're known for their very low noise, and also they are all 4-quadrant amplifiers. So as you think about that, that's where AE Techron sits in the middle of this range of products from low to high frequency. Well, as a part of that, we have two different product lines, if you will, and they are built on different technologies. You think of linear amplifiers as one of those technologies. Ours have very fast slew rates. In fact, our 7224 and 7234s have a 2 microsecond slew rate. That's incredibly fast. They're also known for their very low noise. In fact, our 7224 linear amplifier has noise floors like this. And so if there's a need for that kind of low noise, a lot of times that's happened in the imaging market, such as MRI applications. They need a low signal noise for when they're listening for that signal, and our products are able to deliver that. We're known for that. However, when you think of this, there's a difference between linear then and switch mode, because you see here on this chart, our switch mode amplifiers are able to provide very wide bandwidths, again, from DC to 250 kilohertz and driving full power across that entire bandwidth. But also, as you see in the chart here, low cost per watt. Perhaps you've not made the comparison of a wide bandwidth switch mode amplifier compared to an RF amplifier. And you can see here the difference in cost per watt. But then you compare it to a linear amplifier, and obviously switch mode amplifiers can be incredibly efficient. Now, our wide bandwidth switch mode amplifiers are noisier than our linear amplifiers. But when you compare our switch mode amplifiers to the rest of the industry, our switch mode amplifiers are 2 to 10 times quieter than other switch mode amplifiers out there today relative to their competition. So that's something important to make note of. So there's a couple criteria that are really important that tip the scale from linear to switch mode or from switch mode over to linear. And these are the criteria right here. If the customer's application demands a fast slew rate, well, then you would want to look at a linear amplifier. If they, in their application, need lower noise, well, then you'd want to look towards that linear amplifier. If you think of that low cost per watt, well, that definitely would put the switch mode amplifier to the front of the equation. But then here's a really important question. Are they trying to drive reactive loads? Because if they're trying to drive reactive loads like inductive, capacitive, piezo elements, then switch mode amplifiers really make sense. Let me explain it this way. You're driving an inductive load that's reactive. it is pushing power back into the amplifier. And this linear amplifier, any linear amplifier in the world, the linear technology is such that all it can do with this reactive load and the energy coming back into the amplifier, all it can do with it is dissipate it as heat. And so the warmer and warmer the amplifier got, the faster they were running the amplifier, the longer the amplifier was running as they drove this load, the amplifier just continued to heat up, and then its power began to fall off a cliff. That's what you see here in this chart. Look at the two lines. The top line is a switch mode amplifier, and the bottom line is one of our linear amplifiers driving the same load. And you can see that same thing. That line starts to fall right off because that linear amplifier was getting hotter and hotter and hotter because it was a reactive load. But switch mode amplifiers run differently. That technology takes reactive loads, and as the energy is pushed back into the amplifier, it repurposes it back through the power supply. And so it's able to operate as a much more powerful amplifier. So in this one, this particular amplifier here, it's at 4 kilowatts, and it's able to hold that all the way out from DC to almost to the edge of 250 kilohertz. And some more of our amplifiers lately, you take the 9000 series, for example, it's able to do 5 kilowatts all the way out to the very edge of 250 kilohertz before it would roll off. So again, this is a unique application, but that's one that actually you see in test labs where they're driving reactive loads. Maybe they're doing capacitor testing, or like this, they're driving fans, or it could be a magnetic coil, a Helmholtz coil. All of those things are in test labs all over the world. So this is just an example of when reactive loads is maybe the biggest determining factor sometimes of what would make sense for a customer when it comes to switch mode technology. So when it comes to amplifiers, you have here our 7000 series. We've talked about those today. Very, very powerful, robust solutions. And if it comes to a fast slew rate or low noise, this is the product that will make the most sense. Again, we can scale these in series or in parallel up to 10 units to increase much higher voltage and much higher current. But this would give you some of the power requirement or power ranges as far as requirements here that are listed for you. But this gives you sort of a range of the power and performance of these amplifiers. But then our switch mode amplifiers are laid out a little bit differently because we're able to see here the differences when it comes to either voltage or frequency. We have two series that if it goes from DC to 50 kilohertz and that's your customer's requirements, well then either our 8300 or 8500 switch mode amplifiers would make sense, either of those product lines. But if it happens to be above 200 volts required, well then you're going to need the 8500, right? But then we have two very powerful options that go all the way out from DC to 250 kilohertz, and that would be our 8700 and 9100. Again, voltage requirements, our 8700 is our most powerful switch mode amplifier, and sometimes that's what it will require to get the job done. We can put 10 of those in parallel and drive 600 amps for hours easily. If we put 10 of those in parallel, we'd be able to drive even more current than that. So if we need high current solutions, the 8700 is definitely the way to go. And our 9100 series, 2U of space and able to drive DC to 250 kilohertz at varying ranges of current, very powerful solutions that you have here in our switch mode amplifier lines. What this doesn't show is the current that output for each of these, and that's something that obviously is available on our website, but that's missing. That'd be another axis on this chart, but hopefully this helps you to sort out which of these then would make the most sense based on a couple key power requirements. So those are some of the key fundamental differences that we have between our linear and our switch mode amplifiers. And hopefully this helped make a little more sense of which criteria you should be looking at and questions you should be asking of your customers the next time you're talking with them about AETechron and their applications. Thanks everyone for jumping on the call.